Today we're going to be talking about systems of equations in 3 variables. So far we've talked about systems of equations in 2 variables, which would be something like 2x plus y equals 3 and x plus 3y equals 1. And with these, you would use either substitution or elimination to solve them, and you would figure out that you'd get some kind of coordinate as an answer, right? You get an x comma y, however you want to do it. With 3 variables, just like for 2 variables, you need 2 equations. You actually need 3 equations for a system of equations with 3 variables. So let's start off with an example. If you have 2x minus y plus z equals 10, 4x plus 2y minus 3z equals 10, and x minus 3y plus 2z equals 8. Well, I'm so confused. Where do you even start? There's actually a very simple, or it's not simple, but it's a straightforward set of things that you should always do. The first thing you should always do is make sure that you line up your variables. And you should always do it with your x, your y, your z is equal to some number. Now, whatever's in front of those variables are your coefficients. Those might be different every single time, but you should always line up your variables starting with that. The next thing you should do is, if there are any, in this case we don't, but if there are any, you want to clear all fractions and decimals. And how do you clear all fractions and decimals? Well, let's say that I have a 0.1x plus 0.5y equals 3. Well, I really don't want to deal with decimals, so I can easily clear them all by multiplying both sides by 10. This would give me an x plus 5y equals 30, and that would be a little bit easier to solve. So that's step 2. Step 3, I'm going to number my equations. So in this case, I'd say I'm going to use red. This is equation number 1. This is equation number 2. This is equation number 3. And I want to eliminate one variable at a time. So I'm going to choose a variable to eliminate using 2 of the 3 equations. Usually there's one that's a lot easier than the other, but I have an x, I have a y, and a z here. Well, I have a 2x, a y, a z, a 4x, a 2y, a 3z. In this case, substitution probably isn't the best option. You probably want to use elimination. So just for the sake of numerical order, I'm going to choose equation number 1 and equation number 2. So equation number 1 is 2x minus y plus z equals 10. Equation number 2 is 4x plus 2y minus 3z equals 10. And I want to eliminate one of those variables. What's easiest to do? Well, I see that if I multiplied everything by 3 in the first equation, I would get a 3z. So right here, let's multiply everything times 3. So I'm going to multiply to both sides, which will give me a 30, a 3z, a 3y, and a 6x. And my second equation is going to stay the same. What does it look like I can do now? So I multiplied this first one times 3. I can add these 2 equations together to eliminate this z right here. So I get 0. If I add, this becomes a 40. If I add here, I get a negative y. And if I add here, I get a 10x. So 10x minus y equals 40. I'm going to call that equation number 4. Now, next step that I want to do is choose a different two equations and eliminate the same variable. So I've already used 1 and 2. Let's use 1 and 3 then. So if I use 2x minus y plus z equals 10, that was my equation number 1. And if I use equation number 3, that was x minus 3y plus 2z equals 8. I want to eliminate the same variable, which means I eliminated z here. I also want to eliminate z here, which means I have to multiply this whole equation by a 2 to get those to match, or a negative 2. That way I can add. So multiplying by a negative 2 gives me a negative 4x plus 2y minus 2z equals negative 20. And this equation is going to stay the same. And now I can add these two equations together so that I eliminate my z's. Negative 20 plus 8 is negative 12. 2y plus a negative 3y is a negative y. And negative 4x plus x is a negative 3x. So this is negative 3x minus y equals negative 12. And I'm going to call that equation number 5. From here, I go on to step 5. Now I have these two equations where I just have x's and y's. And that looks a lot like my systems of equations with two variables. So I'm going to solve the system of equations using those two equations that I just made, number 4 and number 5. Not the steps, but number 4 and number 5 here. So that was a 10x minus y equals 40, and a negative 3x minus y equals a negative 12. Looks like my y's are going to cancel as long as I multiply all of this by a negative 1. So this is 10x minus y equals 40, and 3x plus y equals 12. If I add, this becomes a 52 and a 13x. If I divide both sides by 13, I get x is going to equal 4. Perfect. So now I have my first number. How am I going to solve from here? Step 6, I'm going to plug in the answer into 4 or 5. Going to plug it into equation number 4 or number 5. So if x equals 4, I can plug that back into, here's 4 and here's 5. I'm going to plug that back in here like I would normally do. So that's times 4 minus y equals 40. 40 minus y equals 40. So if I subtracted 40 from both sides, then negative y equals 0, or y just equals 0. Great. Now I have an x. I also have a y. And now I just have to find my z by plugging that answer. Step 7 here. Plug both results into equation number 1, equation number 2, or equation number 3. So let's use equation number 1 since I've been using it so often this time. Equation number 1 was, let's go back down here. Equation number 1 was 2x minus y plus z equals 10. If I plug this 4 in for my x, that becomes 2 times 4. If I plug the y in, that's a 0. That equals 10. So this becomes an 8 plus z equals 10, or subtracting 8 from both sides, z equals 2. And that is my answer. And I can check by plugging the coordinates 4, 0, 2 back into any of my first 3 equations. Hope that helps. Let's try a sample problem now. I have 3 equations, and I need to determine which one is probably the best to eliminate, which one of my variables. It looks like the z's, the y's, and the x's are all going to be pretty much the same, so I think I'm actually going to choose my z's to eliminate, because I can multiply this one by 2 to eliminate, multiply it by 4 to eliminate. So let's start out with that first equation and the second equation. So I'm going to take equation 1, which is x plus y plus z equals negative 5, and then take equation 2, which is 2x plus 3y minus 2z equals 8. So based on my list, I am on number 3. Numbering my equations chose to eliminate z from 2 of my 3 equations. In order to do that, I have to multiply the first one times 2. So if I multiply that first one times 2, I get 2x plus 2y. Actually, if I multiply it, no, that's about right. Sorry. Is negative 10. And my second equation is just going to stay the same there. So that was equation 2. This is equation 1. And if I add these two together, I'm going to eliminate my z's. So that gives me a negative 2. That's 0. This is 5y. This is 4x. Now I have to choose a different set of equations, so that's my equation number 4. Different 2 equations to eliminate z again. And I'm going to choose equations 2 and 3 this time. So 2x plus 3y minus 2z equals 8. And x minus y plus 4z equals negative 21. To eliminate my z's, I need to multiply this one by 4. To get, by 2 to get 4x plus 6y minus 4z equals 16. And my third equation is going to stay the same. X minus y plus 4z equals negative 21. And now I'm going to solve by adding those 2 equations together. 16 plus a negative 21 is a negative 5. This is 0. 6y plus a negative y is 5y and a 5x. So my 2 equations are 5x plus 5y equals negative 5, and this one. Looks pretty simple which one I'm going to eliminate. I think I'm going to eliminate that 5y from both. So here's equation 4. Here's equation 5. And I'm going to subtract in order to eliminate this 5y, which will make 0. 4x minus 5x is a negative x. Negative 2 minus a negative 5 is a positive 3. So x must equal a negative 3. So I've gone through step 3. I've chosen 2 other equations that eliminated the same variable, and I solved the system equations using 4 and 5 to get my x. Now, what do? I'm going to plug that back into one of these 2 equations to get my y. So I'm going to plug it into number 4 just because it's there. This is negative 12 plus 5y equals a negative 2. So 5y, if I add 12 to both sides, that becomes a negative 10, and y is going to equal a negative 2. If you add 12, it's going to be a positive 10, and y equals a positive 2. So x equals negative 3, y equals 2. So there's 2 of my solutions. And then I need to plug these 2 back into one of my 3 original equations. I like the first one because there's no coefficients there. So let's choose the first one. My x is negative 3. So x plus y plus z is negative 5. My x is a negative 3. My y is a 2. Plus z is negative 5. This is negative 1 plus z equals negative 5. So adding 1 to both sides, z must equal negative 4. And that is my answer.